So it's been a while since we worked on the Yerf dog. We get a couple of things we have to address. One of the problems that we were having is that when the thing would get hot, it would die, and it would be very hard to restart. You'd have to let it cool down, and then it would be fine again. And what I was able to determine is that I was mistaken as to the theory of operation on this enricher circuit on the carburetor. So instead of having a choke, they still call this a choke in like the wiring diagram, but it isn't actually a choke. By definition, a choke should be something that cuts off the intake air and forces a much richer mixture during starting. The way that this works on this carburetor is there's an additional circuit that allows fuel to flow through it to give it a much richer mixture for starting and when it's cold. So the way that that's accomplished is that underneath this black plastic cover there is a electrical device that actually actuates a pin that sticks out down into a port on the carburetor here. The way that it works is when that port is open, when the pin is not pushed into that port, and that port is open, raw fuel is able to be pulled through that little port and gives you the really rich mixture for cold starting. Then when the engine's hot, the idea is that this pin pushes into that port and shuts off that rich mixture, and the engine runs normally for regular operating temperature. I thought that this was almost like some sort of a solenoid or something, and in fact what it is it's an unusual little heating element inside here, and that's how the whole time delay works. So I thought that as long as we left this disconnected, which we had it completely disconnected, we never wired this into the circuit, I thought that as long as this was disconnected, that it would always be in the hot temperature position, so to speak, and not the cold start position. So I expected it to be difficult to start maybe when it was cold, but that it would run fine when it was hot. And in fact, it actually starts real easily when it's cold, and it was dying when it was hot, the exact opposite. So that's when I did a little more research and realized, oh, the way that this works is when this device is cold and has no voltage attached to it, that pin is out and it's actually in the start position. And then what happens is when the engine starts running and 12 volts becomes available from the magneto, this coil gets this device gets energized through a resistor. That in our case the resistor was broken, but through the resistor the heating element inside here heats up, and when it heats up it pushes that pin out and shuts off that choke circuit for warm operation. So if you're driving along and the engine's hot, this is actually plugged, the port's plugged, and then you shut it off. If this is still warm enough, when you go to restart, the engine is still warm enough, this basically will already be shut off. If you shut it off and it cools down far enough, then this pin will open again. It'll open that port again and be ready to be started as a cold engine. The resistor is critical. If you wire this in direct and you omit the resistor, you're going to probably end up burning this device out. You can buy these separately from the carburetor, but they're still about like $8 for, you know, the cheap Chinese one, and you don't want to have to be replacing this all the time. So the resistor is critical. The resistor, which I have mounted here, let me give you a better look at that. So this is the new resistor that I mounted, and the resistor is approximately a 10 ohm resistor, I think. Yeah, it's a 10 ohm resistor, and the wattage of the original resistor that was in here, I believe, was a 15 watt. It was physically smaller in size. As long as the electrical resistance is correct, you can go up to a higher wattage. In fact, the higher wattage will actually just make it more robust and be able to stand up longer. The resistor that was in here was actually, electrically, it was still measuring okay, but this spade was broken off one of these connections was broken off on it, but I was able to get enough of the wire, exposed wire, touch it with an ohm meter and test it and find out that it was a 10 ohm resistor. I found some wiring diagrams online that just showed the resistor but do not tell you what resistance it is, but then I found a couple that did show it as a 10 ohm resistor. So everything indicates that it's a 10 ohm resistor, and it's in series with this device on the carburetor. So this is a current limiting resistor. If this resistor is not here, if you leave it out, what can happen is too much current can end up flowing through that device on the carburetor and burning it out. So that's why this is important to have in here. I still don't have the voltage regulator in here, and I need the voltage regulator in here to properly wire in the rest of this this enricher circuit device on the carburetor, because you can't wire just 12 volts to this resistor off the battery circuit. You can't take the 12 volt supply off the battery side of the circuit, because what will happen is, as long as the battery is hooked up, 12 volts will be running through this thing, and this thing will be running hot, and it will basically be in the the closed or hot engine run position all the time. Not to mention it's going to run your battery down. So we want this device through the resistor fueled by a 12 volt supply that's only present when the engine is running, so off the magneto side of the circuit. In the meanwhile, we had another problem developed where now the engine won't start. The starter won't turn. And I know the battery's good and charged. In fact, if we short from this post to this post, the starter turns over the engine no problem. So our starter, our non-start problem is either the solenoid is bad or the solenoid is not getting the voltage it needs to close. So we've got to try and diagnose that. One of the possibilities, if you're diagnosing this kind of problem, one of the possibilities could be a faulty brake switch. You're supposed to depress the brake before you can engage the starter. So there's a switch on the bottom. Our switch was bad. I took it apart, cleaned it, and it was good. But then it went bad again. And the reason is it's in a bad location underneath there. It gets very wet. And the original switch was pretty well sealed. But when I took it apart to clean it and put it all back together again, I think the integrity as far as the rubber boot and everything goes was kind of compromised. So for the time being, off to the side here, you can't see it, but I've actually cut the wires going to the brake switch, and I've tied them together. So I'm bypassing the brake switch. So the brake switch is in series with the starter button up on the steering column. So by bypassing that brake switch, really all we have is 12 volts goes out to the button on the starter column and then comes back, and it's supposed to come right back to the actually I think it's on the ground side. Now that I think of it, the switching's on the ground side, because I'm looking at this right here and I'm realizing, yeah, 12 volts is fed to the one end of the coil on the starter solenoid through this wire right here. So 12 volts is always flowing to it, but then you have to ground this wire. So grounding this wire should start the engine. This wire goes through this yellow with a green stripe wire. Again, it goes through the switch that we bypassed up to the starter switch on the column, and then comes back. And then comes back to this ground wire right here on the system ground. So what I'm going to do now is, if I unplug this right here, all right, if I ground this, that starter solenoid should close. All right, so I've got this jumper wire, and I'm just going to put it onto a ground. And now if I touch it to this, nothing.
Doesn't do anything.
Doesn't do anything. That's not good. Not good at all, because that would tend to indicate to me that this starter solenoid has opened. Just for the heck of it, put this on the negative post of the battery terminal, just in case we have a bad ground, but I kind of doubt it. Yeah, nothing. Okay. Did I bring a meter out here? Yes, okay. So And just to verify that our battery didn't go bad sitting here since the last time we actually were messing with this thing, which I kind of doubt, we'll just grab. So I'll go to my same ground point that I was just trying to use, and this is where the battery comes in. And we got 12.5 volts. And as a matter of fact, if I ground my meter, if this coil is not open, then with this ungrounded, floating, so to speak, I should get 12 volts right here. I do. So the coil is good.
No, because...
Yeah, the coil is good. And I could prove that further by making a resistance check of the coil. So now, if I go from here to here, I'm getting... Alright, let me get a different meter. I don't like this meter. This meter's been problematic for me before. See how it just stopped? This little pocket sparing meter usually works pretty well. Let's see, just for the heck of it, let's measure my new resistor just to test it. Alright, your solenoid's bad. Alright, so we want to take the solenoid out. So we're going to disconnect right here, but that's going to leave this cable right here kind of like floating, where it could easily touch something like the frame, which is grounded, and arc. So for safety, I want to disconnect this cable from the battery first, down there.
It's going to be a pain.
Well, you know what?
Remember we tried to put the bolts in and it wouldn't go in correctly, so putting it back in would be a pain.
Yeah, I don't think so. I could disconnect the ground terminal on the battery. It'll have the same effect as the positive terminal, which is taking it out of circuit.
I don't think you need to loosen it that much. There you go. Yeah. All right. Let's see.
So see how this is all rusted right here?
Mm-hmm.
So it's quite possible that water has gotten down inside this piece of crap. I'm going to open this up because I want to see. I'm curious to see if we can see what failed. So I'm back down here at the workbench. This is the original resistor that came out of there. So you can see this wire is actually the end of the wire that's wrapped around a form inside here. This is called a Wirewound resistor. It's literally, this wire has a certain amount of resistance per foot or per inch, and they wrap a certain amount of it together to make this resistor. But by getting a hold of the end of the wire, cleaning the end, I was able to get my meter on here and determine that this is a 10 ohm resistor, because I couldn't find any markings on here that made any sense. That being said, you can go to like these places online that sell buggy parts and stuff like that, and you can find this resistor on there, but you could save yourself a lot of money if instead of buying a resistor made for, you know, sold as a part for a scooter, if you could just find a wire wound 10 ohm resistor of at least 15 watts, which in my case 20 was easier to find, you could buy it for a lot less. So I bought mine at DigiKey. I misplaced the invoice, but DigiKey, you can go online, Google DigiKey, D-I-G-I-K-E-Y, and it's a company that sells a whole bunch of electronics. Oh, here's the bag that it came in. So I bought two because the shipping was actually more than the resistors. So I figured since I was going to pay for that much, I'd buy two just for the heck of it. So, so this is a DigiKey part number, A is in alpha, 102450-ND or O. I can't tell by the way that's printed. But the description is a resistor, chassis mount, 10 ohm, 5% tolerance, 20 watt. And I think these cost me about $3 a piece, and then like $7 to ship the two of them. So it ends up being like $13 for two of them, and I believe if you buy it at a online buggy part retailer, you're going to pay a lot more than that. This is the solenoid, And the way they put this together is this part is inserted into this metal cap, and then they crimp these 3 points right here. So you can take a small blade screwdriver, it just fits in there enough to bend out the metal in these 3 positions, and then you can wiggle this and actually get this whole thing to pop right out. So the reason why it won't come out completely is because the wires go through here and attach to the coil, which is staying behind in this metal part. What they do is during assembly, they have the wires come through here, and then they pour in this material that you can see right here, which is the sealing material. It's like a potting material that's supposed to keep water from being able to get into this. Clearly, something didn't work because I popped this open just a little bit, and you can actually see corrosion down inside there. In fact, it's particularly the top of this plunger right here. That looks like heck. If I can get that out and get a good look at that. There we go. This is wet right now. There's literally water inside here right now. So all of this rain we've been getting has managed to migrate its way down inside here and ruin this. So the lesson learned here is that this probably still would be electrically okay if it didn't get all this water inside of it. So we could probably still buy another cheapo Chinese solenoid, only we're going to have to come up with some way to keep this protected from moisture. I'd love to be able to see the coil to see if it's burned open or what the heck the deal is with that. What would be really funny is if it's just corroded and like the wire broke off because of corrosion. I mean, if we wanted to get super frugal, we could try and repair this if it's not burnt. If the break is really close. See that? That does not want to come out though. The way they made this, they probably somehow they bonded that coil into this. That's the spring. So there's the 2 wires right there. You can see them, those two little, see those 2 little orange things? Those are the copper enamel wires that go into the coil.